Thank you for joining the virtual Graffiti on-demand webinar sponsored by D-Link. Today's topic is What's Up with PoE? Introduction to Power over Ethernet, PoE. Today's presenter is Steve Olin. Steve is the Product Line Director with D-Link. He is a PoE product line industry expert, and he has presented numerous times on switching and switching technologies. Before we hand it over to Steve, let's talk about Virtual Graffiti. Virtual Graffiti has been in business for over 20 years. They have a worldwide presence, and with over 150 brands, including D-Link, they can help you solve many issues with your network and security. Virtual Graffiti, they specialize in network and cyber security. If you need more information on D-Link's products and services, go to D-LinkWorks.com. And if you can't make it to the website, you could always live chat, phone, or email Virtual Graffiti. Now let's hand it over to Steve.
And this is Steve with Product Marketing. I've got a lot to go through today, so I'm just going to jump right into it. Today's discussion is really intended for IT professionals without a lot of networking background, specifically not a lot of background into PoE. So as such, I'm going to go through everything PoE, terminology, definitions. We'll talk about the IEEE standards. I've got a little bit on powering modes and what's called the classification process. But I recognize that there are others on this webinar as well that are probably pretty familiar with networking and power over Ethernet. So I tried to include a little bit of extra information specifically on the new standard 802.3 BT that was just ratified last year by the IEEE. So I've got some slides dedicated to that. Hopefully everybody will come away from today's discussion at least learning a little bit. So after I go through the basics, we'll get into some practical aspects of power over Ethernet. As an IT professional, talk about what are the benefits of power over Ethernet and some common PoE applications. And then as time permits, we get into a little bit more technical. For example, I'd like to talk about PoE power budgets in a PoE switch and what that means. And then we'll wrap up by talking about smart switches, smart PoE switches. We'll compare and contrast a smart switch to an unmanaged switch. Okay, so let's get started on the basics here. Power over Ethernet. It's a system that safely transfers both electrical power and data to remote devices. And it does this using a standard LAN cable, Category 5 or better LAN cable in an Ethernet network. And you see I've got a picture here of a standard RJ45 connector. I think everybody's familiar with that. That's on the end of the LAN cable. There are 8 conductors in that RJ45 or 4 twisted pairs, and we're going to talk a little bit more about that as we proceed through. But what's important to note here is I've emphasized the word safely. And that's one of the reasons why we have IEEE standards. We want to make sure that as this DC power is applied on the LAN cable, we're talking about 50 to 55 volts of DC power. We want to make sure it's done in a safe fashion. So some definitions to get started with. I use these acronyms throughout the presentation, and in the industry you see these all the time. So we need to understand that PSE is power sourcing equipment, and that is the device that provides the power in a PoE network. You can have an end-span PSE located at the end of an Ethernet link segment, or a mid-span, which is located in the middle of the Ethernet link segment. And then at the other end of the cable is the PD, the powered device. This is the device that draws the power or receives the power from the PD. IP cameras, wireless access points, IP phones are all good examples of power over Ethernet PDs. And what's most important to recognize here is that a valid standards compliant PD is going to present a signature in its hardware. It's actually a resistor in the hardware that tells the PSE it is a valid PD. So if the PSE sees that that signature, it will apply the 50 to 55 volts of DC power. If it doesn't see that signature, then from a safety perspective, it does not apply the power. It will still establish Ethernet link. It will still pass data traffic. It just does not apply the DC power, which is the part of PoE. So here's some examples of PSEs. These are all Ethernet PoE switches. There's a 48 port, an 8 port, a little 5 port. These are all end span PSEs. Compare that with some examples here of mid-span PSEs. A mid-span PSE is typically going to have 2 ports, an in and an out. So data goes in, data and power comes out. But even the device on the bottom, it looks like a 48 port switch. That's actually a 24 port mid-span. It has 24 ins and 24 outs. So I think this slide will better illustrate the differences between end span and mid span. So here at the top on the left, we have an Ethernet PoE switch, and you see there's a LAN cable coming out of port 1, and I've color-coded that cable with a dashed red and black, signifying there's both the DC power and the Ethernet data on this LAN cable. And the cable can go per IEEE 802.3 standards. It can go 100 meters maximum. And then on the right side of the screen is the PD. That's, in this case, an IP camera. So the PSE is the Ethernet switch. That's the power source, and it's providing power 100 meters away to the IP camera, or the PD, on the right side. Now compare that with the next example. Here on the left side we have an Ethernet switch, but this is a non-PoE switch. This is just a traditional Ethernet switch. So I'm showing just a black line or a black cable coming out, signifying this is data only. This is just the ones and the zeros, the Ethernet data. And then somewhere along that 100-meter Ethernet link, we have a mid-span PoE injector. So we go into the PoE injector with the data, we come out of the injector with the data and the power. So again, signified by the dashed red and black line. So in this case, the PSE, the power sourcing equipment, is actually the PoE injector that's in the middle of the Ethernet link somewhere. And again, the PD is the IP camera. So a little bit more background. Let's talk about an RJ45 connector. Everybody's familiar with this. As I mentioned earlier, there are 8 wires, 8 conductors, or 4 twisted pairs within a LAN cable. In 10 megabit and 100 megabit, 10-100, 4 of those wires, or 2 pairs, 1, 2, and 3, 6, are carrying the data signals, and 2 pairs, 4, 5, 7, 8, are actually not used in 10-100. Now in gigabit, 1000 base T, and 10 gigabit, 10G base T, all 8 wires, all 4 pairs, 1, 2, 3, 6, 4, 5, and 7, 8, are carrying data traffic. So that's good background to know for upcoming slides. We'll talk quickly now about the IEEE standards. So before 2003, there were no official standards for power over Ethernet. There were certain vendors that were doing proprietary versions. But the thing we have to always consider with proprietary technology is it's not always interoperable. So you could have vendor A doing their proprietary version of PoE on a switch, and vendor B having a proprietary PoE IP camera, and there's no guarantees that they're going to be interoperable. And that's why in 2003 the IEEE ratified the first PoE spec, 802.3 AF. Some people just refer to it as AF or PoE. And that allowed up to 15 watts on any particular port. And I've got more detail on that on the coming slides. In 2009, the IEEE ratified the next version of PoE, 802.3 AT. Some people call this PoE Plus. And this increased the amount of power available on each port. It increased it up to 30 watts per port. And then much more recently, I believe it was in September of last year, the IEEE ratified and released the long-awaited high-power PoE standard 802.3 BT. Some people call this 4-pair power over Ethernet. Some people call it PoE++. But what BT does is allow up to 90 watts of power on any particular port. So let's look at these in a little bit more detail, starting with the original standard AF. Again, ratified in 2003, also referred to as POE Type 1. It makes the available power at the PSE port up to 15.4 watts. And it does this by providing a DC voltage range in the window of 44 to 57 volts DC. And it supports a maximum current of 350 milliamps. Now, the standard recognizes that we can go up to 100 meters on a LAN cable, and we're going to have some voltage drop along that 100 meters. We're going to have some losses due to the resistance of the cable. So the standard ensures that even with the maximum amount of loss, we still have 12.95 watts available to the PD. So again, with AF, 15.4 watts at the source, and ensuring 12.95, we're pretty much 13 watts available at the PD. The standard says Cat 3 is okay, but really recommends Cat 5 or 5E or even Cat 6. And it uses 4 of the 8 conductors or 2 pairs in that LAN cable to transmit the power. So we'll talk about this a little bit more in an upcoming slide, but it's important to recognize here within that 4-pair LAN cable, 2 of the 4 pairs are carrying the DC power. And because this is 802.3 Ethernet, we're supporting cable lengths up to 100 meters. Now the next standard, 802.3 AT, also referred to as PoE Plus or PoE Type 2, increases the available power at the PSE port to 30 watts. And it does this by slightly increasing the minimum amount of voltage, and the window is now 50 to 57 volts of DC power, and it increases the maximum current to 600 milliamps. So again, 30 watts at the PSE port with resistance and loss along that 100 meters, we still ensure that 25.5 watts is available at the PD. Cat 5 cable is okay, but 5E or better is recommended. And again, we're using 4 of the 8 conductors in that cable, or 2 of the twisted pairs, to actually carry that DC power. Cable lengths of 100 meters are supported, and AT is certainly backwards compatible with AF. An 802.3 AT power source can power an AF PD. Now the new standard, 802.3 BT, adds what's called PoE Type 3 and Type 4. Type 4 is on the next slide. Here is Type 3. With a Type 3, we've got up to 60 watts available at the PSE port. After losses, we ensure 51 watts available at the PD. The standard recommends Cat 5e or better. And in this case now, we're using all 8 conductors in the cable. So we're using all 4 pairs to carry that DC power from the PSE to the PD. Cable lengths of 100 meters are still supported. And for the first time, we have a standard that supports PoE over 10G base T, which is 10 gigabit over copper. And PoE Type 3 is backward compatible with both 802.3 AF and AT. And then here's Type 4. Type 4 goes up to 90 watts per port. After losses, about 71 watts available at the PD. With a Type 4, Cat 5e is okay, but 6A or better is recommended. Remember here, the better the cable that we use is typically going to be a heavier wire gauge. If I have a heavier wire gauge, it means I'm going to have less resistance along the way, less loss, and if I have less loss, I have better performance, I get more power out to my PD, and I'm also going to generate less heat within the wires. And if I have a cable bundle of multiple LAN cables, and they're all carrying 60 to 90 watts of PoE power, I could generate some pretty significant heat in that cable binder. So the better cable that I use, the less heat I'm going to generate it and the fewer concerns I'm going to have. With Type 4, again, we're using 8 of the 8 wires, or all 4 pairs in the cable are transmitting the DC power. Cable lengths of 100 meters are still supported, and Type 4 is also compatible with 10G base T. Okay, I want to talk a little bit about powering modes. You probably heard about alternative A and alternative B before. And this is applicable to the older standards, 802.3 AF and AT, that only used 4 of the 8 conductors in the cable to carry the DC power. So alternative A basically uses pair 1, 2 and pair 3, 6 to carry the DC power. Alternative B uses 4, 5, and 7, 8. A PoE switch can support either one to be standards compliant, but a PD needs to be able to support both methods to be standards compliant. So here's some examples. I know this is a little bit technical. I'll go through this quickly. I just wanted to show some examples of alternative A and alternative B. In this example here, we're looking at 10100. And remember, in 10100, data is only carried on 2 pairs, 1, 2, and 3, 6. So I'm representing that with the black wavy lines. And then my spare pairs in 10100 are 4, 5, 7, 8. In this case, since it's alternative B, we're using 4, 5, 7, 8 to carry the DC power that powers that IP camera, or PD, on the right side of the screen. But we don't have to use spare pairs. Here's a case where, again, with 10100, we're using alternative A. And with alternative A, you notice we still have data on 1, 2, and 3, 6, but we also have the power on 1, 2, and 3, 6. So here I've got 2 different systems running on the same copper conductor. I've got the Ethernet data, the ones and the zeros, but I've also got this steady 50 to 55 volts of DC power on that same copper conductor. The data and the power coexist. They don't really know about each other. They don't impact each other. It's done with a technique called phantom power. And the details of phantom power are a little bit beyond the scope of today's discussion, but just recognize that in this case, there's no issues using the same copper conductors for both the Ethernet data and the DC power. And in fact, in this situation, our spare pairs, 4, 5, 7, 8, are still unused. Now, when I get into gigabit, 1000 base T, here's an example with alternative B. Remember, with 1000 base T gigabit, all 8 conductors, all 4 pairs are carrying the data. And then because this is alternative B, I'm actually doing phantom power on 4, 5, 7, 8 to carry the data and the DC power. And then similarly with alternative A and gigabit, same thing, data on all 4 pairs and also phantom power applied to 1, 2, and 3, 6. Now, if we look at the new standard, the 4-pair power over Ethernet, or 802.3bt, it stands to reason we've got data on all 4 pairs, and we're applying phantom power, the PoE power, on all 4 pairs as well. Okay, let's talk a little bit about classification. So classification is basically the lowest common power level that can be supported by both the power sourcing equipment and the powered device. So when you first turn up a PoE circuit, the signature detection that I mentioned earlier, that's of course the first thing that happens. So the PSE looks for that resistor in the PD, sends a very low voltage pulse. It looks for that signature. If it doesn't see that signature because maybe the LAN cable is plugged into a non-PD, maybe the LAN cable is plugged into a laptop, or I'm grabbing that RJ45 with my fingers. It does not see that signature. It will not apply the PoE power. If it does see the signature, it applies the PoE power. The PD boots up, and then we go through the classification process here, shown in step number 2. So the classification is basically a negotiation between the PSE and the PD. This used to be done at the physical layer. Nowadays, with the more modern standards, it's typically done using software, using LLDP, which is Link Layer Discovery Protocol. And it's, as I said, it's negotiation between the PSE and the PD to understand how much power that PD is going to need. If the PD is a small IP phone or an IP camera, and he's only going to need 7 watts maximum to do his thing, then he tells the PSE, hey, I'm a class 2, and there's no reason to reserve any more than 7 watts for me in your power budget. So here are the 9 classifications that are available in the PoE standards. The first 4 were implemented during the first standard, 802.3AF, and you can see class 0, 1, 2, and 3. I used the example of class 2 already, a class 1. If an IP phone classifies himself as a class 1, he's basically telling the PSE, I'm never going to need any more than 3.84 watts, so you can reserve 4 watts for me in your power budget. The class 4 was added with the AT standard, 802.3 AT, and that was 30 watts at the PSE port or 25 watts at the PD side. And then with the newest standard, 802.3 BT, we're adding classes 5, 6, 7, and 8. So class 5 is 45 watts, class 6, 60 watts, class 7, 75 watts, and class 8 up to 90 watts. I've got a little bit more on classification when I get into the next section on this presentation. I'll actually show an example on how a POE power budget works. But I want to talk about a couple of other new features with the new standard, the new 802.3 BT standard. Prior to this standard, everything was done with a single signature. And again, that signature is that resistor that the PSE looks for. But because now with BT, we're actually, in essence, we're using alternative A and alternative B at the same time. In some cases, we might see benefit from having a dual signature system. I can think of an example of an IP camera, a heavy-duty IP camera that's designed for outdoor use. And maybe I'm going to use alternative A, power on 1, 2, 3, 6, for actually lighting up that camera and turning on the IR LEDs and all the things that IP cameras do. And maybe alternative B, 4, 5, 7, 8, is separate power coming in for some kind of a heater or a blower or anything else that's in that camera necessary for it to operate outdoors and to control its environment. The other thing that was added with the new standard is maintained power signature was lowered. So MPS is the amount of standby power needed to keep a port alive. In the case of an IP camera, maybe not so important because IP cameras are typically up and running 24/7. But I think about new applications like LED lighting. LED lighting that's controlled by power or powered by power over Ethernet. When somebody leaves the office at the end of the day and they turn off the lights, we don't want the port to go down. We certainly want the amount of power that's coming out that port to be minimized, but we don't want the port itself to die. So that's what MPS is. And basically with the new standard, they lowered what's called the duty cycle. Bottom line, it's more energy efficient than the previous POE standards. Okay, so that's a pretty good rundown of the basics of power over Ethernet. I want to get into practical aspects now. As an IT professional, what are the benefits? Why would I want to implement power over Ethernet in my networks? Well, for me, the key benefit is flexibility. As an installer, it gives me the ability to put an end device like a wireless access point or an IP camera. I can install that anywhere that I can reach with a LAN cable. I think about a warehouse with really tall ceilings, and I want to put 4 IP cameras in the ceilings in the upper corners of that warehouse. And I may not have AC power drops up there. With a traditional IP camera, I'm going to have an AC to DC power adapter, and I plug that in, and my line is probably about 6 feet from my AC to DC power adapter and plug into my IP camera. But if I don't have AC power drops up there in the corners of my warehouse, I'm going to have to hire an electrician to come in, do the permitting, everything else that's required to put in that AC power. Don't need it with PoE. With PoE, as long as I can reach it with a LAN cable, then I'm good to go. And I've got IT guys that run LAN cables all day, and it's pretty straightforward for them to get the LAN cables up there into the drop ceiling or wherever it is that I want to install my devices. And if I decide I need to move that camera, it's in the wrong place, I want to move it 20 feet to the left, as long as I can move my LAN cable, then it's pretty easy to relocate the device. And again, I don't have to call on an electrician to come and relocate an AC power drop. From a functionality perspective, using PoE lets me reset a device remotely. So for that IP camera that's up in the corner of the warehouse, sometimes can be problematic. I want to reboot it. I just need to disconnect the LAN cable from my PoE switch, connect it back in again, and I've basically just repowered or recycled the power on that camera. PoE is really simple. Again, I mentioned this earlier. I don't need these AC to DC wall wart type of power adapters. All I need is a LAN cable, so I'm minimizing cable clutter at the same time. And then I'm saving costs. I don't have to install power drops or power outlets everywhere I want to put my devices. And especially with outdoor applications, anytime you're running AC outdoors, you have additional safety concerns. Power over Ethernet is considered a low voltage application, so although I might want to run my Ethernet cable in some kind of a environmentally protected conduit, I don't have the same kind of safety concerns running low voltage outdoors as I would with AC power running outdoors. So I'm going to walk through a handful of common PoE applications. You're probably familiar with some of these. In most business buildings today with IP phones, those are all PoE powered. Even some video phones today can be powered by PoE. And if you're running your voice traffic on the same network as your general data traffic and you're nervous about that, there are technologies like VLAN, virtual local area networks, that you can use to keep your VoIP traffic separate from general data traffic. And similarly with IP surveillance, IP cameras are the most common PoE application in the security industry. Most business class IP cameras support PoE. In fact, all business class IP cameras from D-Link are powered by PoE. And again, you can use VLAN to keep surveillance traffic separate from the general data traffic on your company network. And as I mentioned here, the new standard 802.3bt is really becoming more prevalent, really ideal for IP cameras that have high power requirements. Need IP camera that's going outdoors that needs more than the 30 watts that were previously available by the older AT standard. We'll talk a little bit about access control. A lot of door controllers and card readers today are PoE powered. The alternative would be to have AC power near every door. And of course, if we have a power failure, we want our doors to still work, so we would have to have expensive AC power backup at each door location. And that does get costly. But with PoE, I just run a LAN cable from my wiring closet where my PoE switch is located. My LAN cable goes out to every door where it connects into the door controller and the card reader and keeps those powered. And I just need to simply take my PoE switch in the wiring closet and put it on a UPS, an uninterruptible power supply. And as long as that UPS is providing power into my PoE switch during a power failure, all my doors and card readers and door controllers are going to stay alive. So this is a really nice solution for access control and building security. Wireless access points probably should have been the first slide. This is a very, very common application for power over Ethernet. Most business class APs, including all, again, from D-Link, support power over Ethernet on the uplink interface. So anywhere I put my wireless access point, I just have to provide one LAN cable into that AP, and it gets both its power and its uplink from that LAN cable. IP clocks may be an application you're not familiar with. At D-Link, we provide a lot of networking equipment into school systems, K through 12, universities, and they're typically going to have PoE devices in every classroom. They may have a wireless access point in every classroom. They may have an IP camera in every classroom, but they're also going to have a clock in every classroom. And there are IP clocks available today that are PoE powered. And so you have a single LAN cable that provides both the power and the timing data into the back of that clock. There's no need for AC power in that clock. There's no need for batteries that have to be replaced on a occasional basis, just a LAN cable. The timing comes from an NTP server. The NTP server can be within the local network, as shown here in this diagram, or the NTP server can be somewhere out there on the internet. There's plenty of sites today that provide NTP signal for this kind of an application. I think this is a really neat application, whether the clocks are analog clocks, as shown here, or digital clocks. Even during daylight savings, when the clocks advance an hour or go back an hour, that's all done automatically because they're all synchronized to the same time server. Here's another application, Ethernet repeaters. We quite often come across IP surveillance system integrators that have to put cameras in locations that are sometimes beyond the 100 meters that 802.3 Ethernet supports. So we can do an application as shown here. We've got a little mini PoE switch shown in the middle of this slide, the 1100-05 PD. And basically this device is a 5-port Ethernet switch that's powered by PoE. So it's not powered by AC power. It's not powered by an AC to DC adapter. It actually receives, in this case, PoE plus power coming from the larger switch on the left. We can go 100 meters out to the 05 PD, and then it's powered and it has enough power left over to actually propagate or pass through PoE power on 2 of its ports, another 100 meters out to these IP cameras that are maybe out in a parking lot somewhere. So basically what we've done here is we've extended the reach of Ethernet and PoE beyond the 100 meters out to 200 meters. Now, of course, the rules of physics apply here. If I'm only powering the 05 PD with 15 watts of power, I'm not going to have a whole lot left over for those IP cameras that are on the right side. So I have to make sure I obey the power requirements, but as long as I do that, this is a really nice application, a really nice solution for getting PoE power out to cameras beyond 100 meters. Showing POE splitters here. POE splitters are devices that allow me to use PoE technology with non-PoE end devices. Shown here is a non-PoE camera. It could also be a non-PoE access point. And what we're doing is we're running power over Ethernet out 100 meters to the splitter device. And what the splitter does is it splits out the power from the data. So you can see the outputs on the splitter. There's an RJ45. That's just 10100 to 1000 Ethernet data going into the back of that camera. And then there's a barrel connector. There's a power connector that can provide either 5, 9, or 12 volts of DC to my non-PoE camera. In fact, the D-Link splitter that's shown here has a little slide switch on it, and I can select 5, 9, or 12 volts as my output. So again, this is a nice way to use power over Ethernet with a non-PoE end device. LED lighting, I mentioned just briefly, is a newer application that's coming out, especially with the new 802.3 BT standard. A lot of times these LED lights up in the ceiling tiles of a business building are daisy chained together, and so while each LED itself doesn't consume a lot of power, as you put chains of these together, higher power needs come about. And that's where 802.3 BT with its 60 to 90 watts of power output is really handy. And as I mentioned earlier, again, power over Ethernet is considered a low voltage application. So I can have my IT guys actually install my PoE lighting throughout my business building or school or medical hospital building. I don't have to worry about conduits for AC power. I don't have to worry about licensed electricians. So this is a new and emerging application that's coming, that's been boosted by the new BT standard. Other applications we don't really have time for today, intercoms, paging, PA systems. We work very closely with a company called A-Phone, and they make a lot of these devices that are shown here. And many, if not all of their devices are PoE powered. There are digital signage and video kiosks that are PoE powered, and then environmental and industrial type of sensors that you can also get and power them through PoE. So, summary on applications. PoE, it's really ideal for schools, business buildings, hospitals, healthcare, hotels, retail, anywhere that they're installing IP cameras or IP clocks, LED lighting, IP phones, wireless access points. Really a nice, simple to use technology that minimizes cable clutter, minimizes my costs when it comes to having to do permits and have licensed electricians come in. I can do most of this, if not all, by myself with my staff and my guys who run LAN cables all day. Okay, I want to go into the last part now here, talk a little bit about more detail on a PoE switch power budget, because when you're shopping for PoE switches, that's certainly one of the main considerations to take into account. So the power budget on a PoE switch is basically the total amount of power that's available in that switch. Now this power can be allocated across all the PoE ports as needed. Maybe port 1 is 4 watts, port 2 is 15 watts, port 3 is 30 watts. I just allocate that as needed. And I recognize that all PoE switches are different. Some PoE switches have what we call a full AF power budget, which is 15 watts supported on every PoE port. To make the math easy, if we're talking about a 10-port switch, that would be a 150 watt power budget. Some switches actually have full AT power budgets. A 10-port switch in this case would be a 300 watt power budget, supporting simultaneous 30 watts across all 10 ports. But many PoE switches have less than that. You don't always need a full power budget depending on your application. And keep in mind, the higher the power budget in the PoE switch typically is going to impact the cost, higher cost. May also have thermal considerations. We have a PoE switch with a 65 watt budget, has no fans. It doesn't need fans for cooling, so it's silent. Our PoE switch with a 370 watt budget, of course, is going to have fans in it. When it's providing that much power, it needs to do some cooling, so it's going to make a little bit of noise. So there are other considerations as well when you're looking at PoE power budget. Let's look at some real live examples here. I'm showing a 5-port switch, an 8-port switch, and another 8-port switch. The 5-port on the left, the DGS1005P, 4 of its ports support power over Ethernet, and because it's an AT switch, any of those ports can go to 30 watts. The switch has a total PoE power budget of 60 watts. So if all 4 PoE ports were providing PoE at the same time, it would average out to about 15 watts per port. But again, I could go 30 watts on port 1 and 30 watts on port 4. I don't have to necessarily spread it out. I'm just showing an average here. And comparing that with the switch in the middle, the 121010P, which is actually our best-selling smart switch, and it has a 65 watt power budget, and it's an 8-port switch. So on average, it's supporting about 8 watts per port. And that's because a lot of our customers recognize if they're powering a network of IP phones or other low-power devices, an IP phone is going to draw 4 or 5 watts. So a switch that can support simultaneous 8 watts on each port is more than adequate. And then compare that to the switch on the right, the DIS200G. This is an industrial switch, also supports AT. It has a full 240 watt power budget across its 8 power over Ethernet ports. So in this case, this is a pretty robust heavy-duty switch, and it can provide 30 watts across all 8 PoE ports simultaneously. But the thing to keep in mind here is that PDs only draw as much power as they need. So again, if I'm powering IP phones, I can take that into consideration. If I'm putting in a surveillance network and I want to future-proof it, I may swap out my cameras in a few years that have higher power requirements, then maybe now's the time to put in a beefy PoE switch with a robust budget. Every application is different. So I'll show another example here. This is the DGS1110 MPP. This is a new switch we have that supports the new 802.3 BT standard, the high power standard, on ports 7 and 8. So this is an 8-port switch. In fact, let's show the whole table here. This is an 8-port PoE switch. First 6 ports can go up to 30 watts each. Ports 7 and 8 can go up to 90 watts each. And here I'm fictitiously connecting it to ports 1 and 2 are connected to IP cameras. One's a class 2, one's a class 1. Ports 3 and 4 are connected to IP phones, and they've declared themselves as class 2s. And you can see here next to the classification, the IP phones are class 2s, so the switch says, okay, I'm going to reserve 7 watts on each port for the class 2s. Port 5 is connected to a class 4 access point, so the switch says I'll save 30 watts for you. 15 watts on port 6. Port 7 is connected to a high power IP camera. That's a class 6. So the switch says I've got 60 watts reserved for you. And port 8 is connected to some LED lighting, and that's class 7, and the switch reserves 75 watts. So over on the right side of the screen, you see a total power requirement of 205 watts to power all of these PDs. And this particular switch that we're looking at has a 242 watt power budget, so I've sized my network accordingly here. I've got the right switch for the right applications. Okay, in the remaining amount of time, let's quickly talk about types of PoE switches. I usually start from the bottom and work up. I think most people are familiar with an unmanaged switch. An unmanaged switch is simple. I power it, I plug in my cables, turn it on, and it forwards Ethernet frames all day. It's not configurable. There's not much I can do with it. It's an unmanaged switch. Whereas a smart switch has management capabilities. I'm typically going to use a web browser, and I'm going to view the graphical user interface of this switch, and it allows me to configure a limited set of layer 2 and layer 2 plus types of features within that switch. And then a fully managed switch is a smart switch and more. Fully managed switch is typically also going to have the graphical user interface, but it will also have a console port that allows me to manage using a command line interface if I'm more comfortable configuring the switch in that fashion, and I'll typically have a full suite of layer 2 and layer 3 functions. What I want to talk about today, though, is focus on a smart switch and compare that to an unmanaged PoE switch. A smart switch is usually just a few dollars more than an unmanaged switch, but with that I get really a compelling set of features within my PoE switch. So for smart PoE, advantages of a smart switch versus unmanaged switch. With that graphical user interface that's showing here, I get real-time power statistics. I get power-saving features. The graphical user interface shows me exactly how much power my switch is using. Not only does it tell me how much is reserved in the power budget, but it will tell me on port 1, I'm actually providing 2 watts. On port 2, I'm providing 15 watts. It gives me that visibility, which I don't get with an unmanaged switch. It allows me to prioritize ports. So some ports can be prioritized as more important than others. And so as I'm turning up additional ports with PoE, if I do approach that budget, my switch knows which ones to stay powered because they're higher priority. And I can create PoE time profiles. So I can go into the management of my smart switch, and I can say, hey, on port number 7, I want you to turn on the PoE power at 7 o'clock in the morning, and I want you to turn off the PoE power at 5 o'clock in the afternoon. Why would I want to do that? Maybe my port 7 is connected to a wireless access point, and I actually want to power it on and power it off during certain times of the day. The really nice thing about smart PoE switches is we can control PoE power from anywhere at any time. I've talked to IP surveillance installers and system integrators before that have told me stories about getting calls at 3 o'clock in the morning. Hey, the IP camera out in the parking lot of this business building is locked up. It needs to be rebooted. And in the old school way would be to do a truck roll, send somebody down there to reboot that camera. But as long as I have network access into that switch, or maybe it's even a cloud-controlled or cloud-managed switch, then from my living room at 3 o'clock in the morning, I can VPN in or connect into the cloud portal and manage that switch. And I can very simply power down port 7 and power back up port 7. And in essence, what I've done is just recycled the power on that particular camera. We've taken that feature one step further on many of our smart switches with something we call PD Alive. With PD Alive, the smart switch actually does this automatically. So if PD Alive is enabled, the smart switch will send pings on a periodic basis to the PD that can be configured anywhere from 10 to 300 seconds between pings. And of course, the switch is going to expect a reply to that ping each time. If it does not receive a reply within a set number of fails, then it will actually power down and power back up that particular port. Basically what we're doing here is rebooting a problematic IP camera or a wireless access point that's not responding to pings anymore. So in the example here on the lower right, we see a ping, there's a reply, another ping, there's a reply, a third ping, No reply. 30 seconds later, we try again. No reply. We've told the switch after 2 failed replies to go ahead and reboot. So it powers down port 4, PoE power, and then it turns back on the PoE power. And optionally can send me a notification, hey, IT manager, I just sent or just rebooted port 4. Here's your notification letting you know what I just did. So this is a really nice feature that we have in a lot of our smart switches today that take a lot of the manual troubleshooting out of PoE networks. So here to wrap up, I'm showing just some example GUI screens from some of our smart switches. And here, this is the main screen of a smart switch. And on the right-hand side, we see the basic switch information, its serial number, its MAC address, what firmware is loaded. And on the left side, there's this tree, a menu tree of different items. And if I were to expand out the plus sign next to PoE, you see I have a lot of different functions here. And when I click on this particular screen, I'm looking at all 8 ports. This is an 8-port PoE switch. And it tells me all 8 ports are currently delivering power over Ethernet. It shows me the classification as these devices classified themselves. There's 1, 2, 3, 4 class zeros, a couple class 2s, a couple class 4s. It shows me how much power they've reserved. The switch has reserved for these PDs, and it shows me how much power is currently being used. And you can see in all cases, a lot less power is actually being consumed than what is budgeted for in the switch's power budget. Now maybe it's daytime and IP cameras have not turned on their IR LEDs that they use at night, so this power consumption here will fluctuate as network conditions change. But the intent is to show you the visibility you have into the network with a smart switch that you don't have with an unmanaged switch. We also have something called surveillance mode. This is an alternate view of the user interface that we have in a lot of our smart switches. With surveillance mode, it's the same information. It's just presented in a more graphical format. So here you see 8-port switch. It's connected to 8 IP cameras. With surveillance mode, the switch will actually do an on-VIF auto discovery. On-VIF is it's an IP surveillance protocol, and it reaches out, and if it discovers IP cameras connected to its port, it actually shows me these icons here of the IP cameras. And if I were to mouse over these icons, it would give me additional information. It would tell me the IP address of each device. It would tell me how much power is being consumed. So again, surveillance mode, same information, just presented in a more graphical format. On the device information tab here, it shows me out of my maximum 242 watts, I'm only using about 11% of that PoE power right now. And of course, there's a lot more PoE information that I can configure from here, including the time schedules that we talked about on a previous slide. Okay, so that's it. That's kind of a wrap-up of all things PoE, what we talked about today. To me, the most important, IEEE standards. We had the different standards, 802.3 AF, AT, and the standard that was ratified last year, 802.3 BT. Why do we need standards? Interoperability, of course. We want to make sure that vendor A switch is interoperable with vendor B's access point or IP camera or IP phone, but it also ensures that we have safety built into to the technology. We talked about the benefits of PoE, saves money, minimizes cable clutter, no need for AC to DC power adapters, no need to have electricians come out and install AC power drops because PoE is considered a low voltage application. We talked about PoE power budgets and the different kind of PoE switches that are available. Some have pretty robust budgets. Some have lighter, thinner budgets. They're different switches for different applications. And it's important when you're designing a network to understand what kind of power requirements you're going to have so you can size your power budget accordingly. And then I talked a little bit about smart PoE switches and tried to make a compelling case that for just a few dollars more, you can utilize a smart PoE switch instead of an unmanaged PoE switch and really get the capabilities, tools, and benefits that you would not otherwise get with an unmanaged switch.